experiment, that is verification of Ohm's law. What is Ohm's law? Ohm's law, what is Ohm's law? V is equals to? No, that is not Ohm's law. Ohm's law statements of Ohm's law states that if temperature and other things remains conserved, then what? The current is proportional to applied voltage. Okay? So if I do it, if I write I is equals to your K times V. K is some kind of constant. Okay? Some constant. Okay? So V is equals to I by K. So I can write it in another constant, that is R. Okay. Here 1 by K is R. So all of you know that V is equals to IR. This thing is familiar to you. Okay. So this is actually Ohm's law is this one. I is proportional to V. It is not V is proportional to I. Okay. So what we have to do? We will apply some kind of voltage. Okay. We will apply some kind of voltage and we will note the current. Okay. And you have to plot some kind of graph. If this graph is a perfectly straight line, you know y is equals to mx plus c. It is the equation of a straight line. Okay. So if from here you look, so V is equals to IR. So if I plot V versus I or I versus V, it will be a straight line. If it is perfectly straight line, then we can tell that Ohm's law is verified. So in x-axis and y-axis, what should be the axis? X-axis should be your independent variable. Here independent variable is what? Voltage, of course. So in x-axis it will be voltage. In y-axis it will be current. And always write unit here. Okay? Don't forget it. Unitless quantity is meaningless. Here also you have to write. Okay? Suppose I will take some kind of data. Okay? I will take some kind of data, that is your V versus I. Okay. I will apply voltage and current. Suppose serial number 1, 2, 3, some kind of like this. Suppose your serial number. Okay. 1, 2, 3, 4, like this. Suppose you apply 1, you get here 2, here 4, 3, 6, like 6.5 or something else. 4, it is 8.6 like this. You get this thing. So you, from experimental data, you get this thing. Next thing, what you have to do? You will plot this thing. Okay. Suppose for 1. So this is for 1. When voltage is 1, current is 2. It is 2. So you got point here. And for the second thing, you got here. Third, this 4 point you will get. Okay. After that, you have to draw in such a way so that if it is all the points in a straight line, then it is very fine. Okay. But in experimental case, it will not be there. All points will not be in a same point. Okay. In same straight line. So you will draw a straight line in such a way so that all points are close to that straight line. Okay. Like that. So if it is straight line, then your Ohm's law verification is over. That means from this experiment you can say that we have verified the Ohm's law, or this conductor whatever we are using, it obeys Ohm's law. Okay? Any question? That means for a particular voltage you have to note down the current. Okay? And till now it is okay. I will go to the circuit diagram. DC power supply. Next thing is resistance. This thing is rheostat. How many of you know rheostat? Do you see rheostat? I will introduce it. Okay. Today we will see the rheostat. And this is your ammeter. Okay. Similar kind of arrangement I have done here. This is key, some kind of switch, or it is called key. Okay. If you close the switch, current will flow. Which direction current will flow? In this way. Okay. So you will apply some kind of voltage and you note down the current. You have to note it down. Okay. According to this, okay, I will explain why we have used rheostat. Here I have used some kind of ammeter to measure the current. Okay. If your voltage is very much and your ammeter is unable to catch that range. Suppose your ammeter range is 0 to 50 million. Okay. And whatever you are using the experimental component, it shows that current will be like 1 ampere. 1 ampere is very much high compared to 50 million. So you cannot catch this current with this this ammeter. So what you need to do? You need to apply some kind of resistance. You insert some kind of resistance so that this range, it will be in this range. Rheostat is actually variable resistance. You can vary. You can take according to your choice. Okay. So that's why we are using rheostat. Okay. Any question? Okay, now then come to this experimental setup. This is the experimental setup. Okay. So look at it. Whatever I told, that is the rheostat. It is actually variable resistance. Okay. I will explain one by one. It is DC power supply from 0 to, is written here, 0 to 12 volt. Okay. DC power supply. And I told in class, this is red and this is black. Why?
Positive and negative.
It is positive, it is negative. It is written here. Yeah, it is written positive and negative. Okay. This is rheostat. It is actually it acts like a variable resistance. Okay. It is rheostat. It is ammeter. It is resistance box. Look at this. Here it is written 1, 2, 2, 5, 10, 20. Okay. It is infinity. Do not open this one. Okay. If you open it, when you want to insert some resistance, you have to open the lid. That means you applied that resistance. Okay. Now I have applied 100 ohm. Okay. So like this. One beauty is also there. Can anyone see? That is the ratio of this thing. Is 5:2:2:1, like resistance box. Why it is so? Because any kind of resistance you can apply. Okay. Suppose you want to 86. So if you apply this combination, you can get this. Okay. And this is key. Okay. If you open it, that means it is cut. No current will flow. Okay. And look at this rheostat. Okay. Yeah. See it. Okay. It is full 12.2. I am changing the resistance. Current is also changing. Because resistance in this circuit is changing. Why? Rheostat. Rheostat is nothing but a variable resistance. Okay? So what you have to do, you have to just make a table. Okay? It is 0. It is 0. Suppose it is your it is 1. You have to note it. Okay? 2. You have to note it. Like similar way you have to do. Okay? 0 to 12 volt. At least take 10 reading, and after that draw this graph. If graph is straight line, that means your Ohm's law is verified. Any questions? Okay, perform it.
Okay, after performing the experiment, we got the data, that is applied voltage versus current. Okay, so corresponding applied voltage, we got the current, and after that I am trying to plot in Excel. Okay, so along x-axis, carefully along x-axis I have plotted applied voltage. Okay, and along y-axis I have plotted current. Okay, corresponding current, and after this I have fitted with a straight line, and I got the relation, that is I is equals to 3.2799 volt plus something. Okay, so also we can find the slope of this graph using some Excel command. Okay, so slope is we have, and you can see that is the slope of current versus applied voltage. Okay, current versus applied voltage, it gives the conductance or 1 by resistance of this. Okay, so in order to get resistance, what you need to do, we need to just inverse of this slope. Okay, so slope, so resistance is 1 by this slope. Okay, and also one can get the slope of this, since we got the relation I is equals to 3.2799 V, that is y is equals to mx plus c something relation, so m is the slope. From there also we can get the slope. Okay, and look carefully, the unit of this resistance will be in kilo ohm, since the current is in milliampere and applied voltage is in volt. Okay, so the unit of this thing will be in kilo ohm. Okay, so from this experimental observation, we can conclude that here Ohm's law verified nicely, since it is fitted with a straight line graph. Okay, or yeah, one can say that the whatever we are using, that is the conductor obeys Ohm's law nicely. Okay, so in another video I will show how to draw the graph manually. Okay, using graph paper. In this case we are using some kind of Excel. So in another video I will show how to draw the graph manually using graph paper. Okay, so that's all about Ohm's law.